lesson on classes. So, hey, slide says class. Then the slide says class simple. Looks like this might be a class definition or something. So why don't you type it out on the, and we're using Visual Studio Code to write the code. So, so I just wrote the keyword. So when you define or declare a class, you use the word class. You use the keyword class, lowercase c, and then you put the name of the class. In my case, I'm calling it simple. And as you see, S is an uppercase S. So do that. So these are conventions. And then I am going to put a colon after that. Colon says that something got declared, and the definition of that something will come in a block after the colon. So colon indicates all of that. So there's going to be an indented block of code after the colon. So I hit enter, and you can see that Visual Studio Code moved my cursor 4 spaces to the right. And now I'm gonna declare a variable called X and give it the value, an int value of 5 to it. And now I'm going to hit enter, and I am done. I've just declared a class, and it has one variable in it. Okay. And so if I compile it, so let's do that. I can hit this key, the play key here. And it wants me to save this file. So let me save that. I'll call it lesson 5. And I should save it with the extension py. So I could do .py, but I don't need to because it says Python already. Doing it from here. No, run without debugging. And I did not get any errors. So if you look at, let me pull this up here. If you get a cursor, so here we have this cursors right here sitting here, right? Users Ali Python lessons. This was the directory in which I saved the file, and this is the end. This says, if you look at the right, this says PS C. It says that something was executed that was in this directory, and that something did not output anything, but it got compiled and executed properly, and so there is no error message here. Okay, let's put an error message here. So let's say I take the colon out. Okay, now if I compile it, it's going to give me an error message right here somewhere. So let's see if we get that. So this is a quick review. So I go run without debugging. And again, if I pull this up, you can see the whole thing. This is from the previous running of the file. This is the second time that we just compiled and executed the file. And it says that there was a missing colon right there, a syntax error. It says syntax error, invalid syntax, and now we have the cursor right here. So the error messages are here. So all we have to do is put the colon back. And then if I run it, run without bugging. This is the third time that the file has got run. Let me do this. This is the third time it ran, and there are no errors. Also no output, nothing happened. All right. All that happened was that this in the memory of the computer, there's a name called simple. We have in the memory something called simple. So the class has been declared, it exists. Now we can create objects from it. Okay. So I'm going to make this small. So let's see what the next slide says. So if you go to the next slide, it says that we define classes by using the keyword class followed by the name of the class. So this is class definition declaration. This is a very simple class. Usually classes have both variables
Oh, and function.
and functions. This class only has one variable. Okay. What kind of variable is that? Well,
It's an integer.
it's an int. Yes, so that's the data type of the variable. And this kind of variable, which sits right below the name of the class, a variable declaration that is not inside a function of the class or not inside the explicit constructor of the class is called a class variable. So what happens is that if we made 15 objects of this class, there will be only one copy of this class variable. So class variables are shared by all the objects that we instantiate from it. So let's keep going. Let's go to the next stanza. Not next stanza. The next, sorry.
This is computer science.
It's a thing that getting messed up. The next slide says that this is a very basic class that contains one variable and no methods. Method is a fancy word for a function in computer science when the function shows up inside a class definition. All right, next. This one says that this class declaration or definition begins on line 1 and ends. So by line 3, we are done defining this class. This is a very tiny class. Let's keep going. Now we have a slide that says the next slides will be talking about what class variables are, which I just talked about earlier, right?
Right.
So let's go here. It says, when a variable such as X is declared inside the indented block of the class, indented block of the class starts here. This indentation, these are 4 spaces here. You'll get a variable here, another variable, functions, constructor, all kinds of things. In other words, there could be in this indented block, you could have my word. Now we have 2 class variables. X, which contains or points to a int 5. My word is a reference variable that points to a string called cat. So now we got 2 data types. Let's say I throw in a function here. A function could be like this. A function get my word. So and this might just return my word. So now my class has what? My class has there's some issues here. Okay, my class has sorry. So this simple class now has 2 variables.
2 class variables.
2 class variables, very good. And a method. And the keyword when you define a method is the def. Then you give the function name or the method name, parentheses, then you put that colon again to indicate that whatever comes after that indented block after this declaration will be the body of the function, right? And inside this method, let's say if I define y, let's call it z. This would be called a local variable. Okay, and I could even just do this. Right, should we run this? So we have a int, we have a string variable, we have a function called get my word. It doesn't return cat, it actually returns the value of 10, right? So let's run it. So I'm gonna just make this bigger here. So here we go. So we are going to run without debugging, and it ran it. Nothing happened. Is there something wrong with this class?
Pound symbol because this is Python.
Oh, so this was
So
a
maybe it's like a
no. It should have been a.
Yeah, so it might have.
It would have croaked on that if I ran it.
I see.
But it didn't for some weird. Oh no, it did. It did give us. Oh look, it did give a invalid syntax error.
Oh, I see. Because
And-
I'm getting unexpected indent.
Yeah. So right then, I didn't pay attention to the error message at all. Thank you. So now if you run it, it should work, right? Yes. In my case.
Okay, now it works. Yeah.
Very good. Thank you for.
I had an extra.
All
thing.
right. Very good. Very good. All right. So now let's run it. No, so now we have to instantiate an object from this class that will allow us access to the functions
Mm.
and also the variable stored in this class. So let's call my reference variable that will then point to the object of this class. Let's call this sim obj equals. So I've now come up with a name for a reference variable because this variable will point to the object. I need to do something on the right hand side that creates an object of this class that I've just defined and declared.
I see.
So in other words, I need to call the constructor function of this class.
Mm.
And the constructor function of this class, is it here anywhere? No. We have a regular function here, get my word. That doesn't seem like a constructor.
Gotcha.
We need an actual constructor. We need to make a constructor call. And usually the constructor method of a class has the same name as the class name.
Oh,
So even though it's not defined here, Python will give us a default. Python already has a default constructor for this class. And the constructor for the class, whether you write it out here explicitly or not, is called simple. It will have the same name as the class name. So this is the constructor. Simple is the name of the constructor of this class. Okay. Now if I run this, it worked. So now what's happened in line 9 right here is on the right hand side of the assignment statement as assignment operator. Equal to is not a math equality operator. This is the assignment operator. Whatever is on the right hand side, assign it to what's on the left hand side.
Mm.
So on the left hand side is a reference variable. It refers to, now it has been assigned the object that the call to this constructor simple created. So now we can do this. We can print sim. We can use our reference variable and we can treat the reference variable as if it is the actual object, even though it's something that points to a simple object that is stored somewhere in the memory that contains these two variables and this method here. So first thing I'm going to do is I'm going to use the reference variable or the object, use the dot notation. I put the period there, and I'm going to call this function on this object that I instantiated on line 9. So I'm going to say get my word and now if I run it, so in other words, after line 9 gets executed, I have an object that I can use to go inside the object inside. So after line 9, there is an object existing in the memory. It's not a class anymore. Class was the design for that object. You took, so this whole from line 1 to line 7 was the design, the blueprint for an object that we put in the memory. Then we instantiated an object on the right hand side and assigned it. And so now sim of the reference variable points to that object, which contains those two variables in that method. We can also think of sim obj as the object itself. So now we use the name of the reference variable of the object, use the dot notation to access the method inside that object. And if we call, so this invokes this method. When this method gets run, this whole line here from S all the way to this parenthesis will be replaced by the value contained by Z. Because when this method gets called, the first thing that happens is that z gets assigned the value 10. And then the second line of code in this function says return this. Z gets returned. When z shows up here, the computer then finds out the value of z, and that's what gets printed out. So if I run this, I get an error. Let's see what happened. Oh. Did it work for you? Or?
No, same error.
When we define a method or a function outside of a class definition, this would have worked. If this function, I can do this. Let me take this function here, and I'll just put it here. If I had defined this method, and then if I define this method outside of a class definition and then called it, it would have worked. So the computer would see the definitions right here, and it would run it, and it would not say that the positional, the error was saying that in the definition, the positional argument was missing. There was one argument that I had not placed right here. And that argument is called self. Self is the first argument that we have to write out in any function definition inside the class declaration. But if you do it outside, you don't have to. So I'm gonna wait for that. Now if I run it, it works and it prints out 10. Because when it comes to line, so it's okay with the way the class is defined, because it's at runtime that it catches problems, right? So it comes here, it says this is fine, I don't care whether this thing works or not. Syntactically, it's fine. So it does syntax checking, but not runtime checking. Then it says, okay, there's a method inside the class that has the name getMyWord. There's one outside, and that's fine because that's stored inside. So the name confusion is that is not a problem yet. It says it's a well-defined function. So then when I invoke the function or call the function from inside this print function, this is the function that gets called. And since it does not need self as the first argument, which is a keyword, it works. So now what I'm going to do is I'm going to delete this, and now it won't work. Will this work? Actually,
Sorry,
it won't work because
it's stored inside the class.
yeah, it's hidden, right? It's hidden, stored inside the class. It doesn't have access to it. So in other words, to access this, I need to put the name. I need to access the class, the function hidden in the class or in the object by using the dot notation, which is this period that I just put in there. Now I've accessed. This will still not work because the method definition is wrong. It needed this argument. So now let's run it. And it works. What is that argument? What this argument is, basically, that argument identifies.
It identifies that the method should run its function. I guess I use the same, but is that right?
That's kind of right. Basically, self, in other words, when I run this, self is passed in explicitly. Self is something that points directly to this, because what happens is, okay, so if I did 2, which objects getByWord needs to be called? Object sim obs get my word function should be called, or the other object we have instantiated. And what happens is when you do this, self gets passed in, and self is a pointer. When we do this, self points to opt2 only. So in the memory, self takes us to the right object and runs the right method from that specific object only.
Oh, I see.
And then when we, if I had written this, self, which we pass in implicitly, then it becomes an actual explicit argument here. So when this goes, it says, go to the correct one. Okay, and this will get clearer once we get to the, we've been looking at class variables, once we get to the instance variables. Okay, so let's keep going. This we were calling a local variable. So there are three types of variables you can declare in a class. A class variable, which is shared by all the objects of the class. A local variable defined inside a regular function. What if we, then the third type of variable is called the instance variable, and those are declared inside the constructor. So let's write a constructor. Let's throw in an actual explicit constructor. So how do we define a constructor? We do def again, because it's a function. And then, the constructor, for some weird reason, in Python is called underscore init underscore. In Java, the constructor name is the same as the class name. If you were doing Java, I would have written simple here. When we call, now if we go to line 11, it's going to call, it's not going to call the default constructor. So on line 11, this call to simple, this function call actually will invoke this thing.
I see.
Okay. And of course, in a function, we need these two guys. And then we need the colon, and then the function body. Right? So right now I'm just going to put pass in there. Oh. And let me run this. So let's do something with this object too. So print same opt dot, let me print out X. All right, I'm kind of taking out space so we can see it, right? All right, so here we go. So, oh, and I already had this. So my contention is now when I call on line 10 now, it's line 10, when simple gets invoked, the function that actually runs is this one. And what does this function do? Nothing.
Doesn't do anything.
Pass says, move on, you're done. You need something in the function body. So Python came up with this keyword pass.
I see.
Don't do nothing. That's what it's saying. Don't do nothing. Okay, so let's run this. And hopefully there are no error messages. Oh. Why did it fail? It says the constructor takes a positional argument 1 that was not given. Any method, function, constructor defined inside the class needs to have as its first argument self. Yes, thank you. See how I keep forgetting?
Yeah.
It's obvious I'm not a Python programmer. All right, see it works.
Yeah.
Line 11 printed out 5, line 12 printed out 10, right?
Sure.
Okay, I'm going to just make this better. Z is going to be actually dog. Now Z is actually a data type string. That is actually better. So let me run this again. I like that. There we go. Got the 5 and the dog. Now I'm going to type something that is really strange. So we were able to access the class variable. This is a class variable, right?
Mm-hmm.
And we still haven't got to the instance variable. right? We still haven't. We have a local variable defined inside a generic accessor method is what this is called. And then we have the constructor. This is the constructor.
Wait, what kind of method is this called?
Accessor. It goes in and accesses stuff in there. In fact, this is what it could do.
How do you spell that?
I'm going to type it accessor. Sorry. This is an accessor method. Accessor. Okay. And then I'm taking the local variable. No, we can keep the local variable too. Let's do this. We have a local variable z that equals 10, but now I want my accessor method to return x, the class variable. So now I have access to the class variable through my accessor method. I can also access this. So now when I call get my word, it's going to return the value of x, because it's going to go here. It's going to say, hey, oh, it didn't like it. I think it's not going to work. Let's see.
Yeah, I think it says x is now defined.
Yeah, it isn't defined. You know what it needs? See the squiggly disappeared? It says go to the class variable x in this object. So self is saying the x that I want you to return is the x of the specific instance. So this self takes you straight there. Okay, let's run this. And I don't really understand any of this, but I'm just saying it.
So what I'm hearing is, if anything's not working in class, just write self in it, and that'll probably fix it.
If you want, yes, in other words, if you want to access the class variable inside a method, put self there.
Gotcha.
Okay. So this is all good. Now is the time to do this. We're going to go to our constructor, because it's in the constructor method where the instance variables are defined.
I see.
So let's define an instance variable. We're going to have a y equals 15. Now this is
That's
a
a local variable.
instance variable.
Wow.
Yeah, local variable is in any given method or function. In the
Oh, I see.
in the constructor method, which is the special method, is where you put the class, the instance variables.
So this init one, that's the
This is the constructor method.
gotcha.
Okay, so now what's happened? Actually, you are right. No, you're not right. No, that is true.
Because this is a constructor method, so it wouldn't I don't know.
This weird thing is the constructor.
Yeah.
And in this constructor, what we've done is we have declared an instance variable called y and initialize it to 15. The init is the word initialization.
Sure.
So constructor method initializes the values that are stored in the variable. In this, we could have also done this. We could have also, and let's see if it works. And now we can take out the word pass, right? We don't need that anymore. Let's see what happens. I think there's something still off with all this, but no, it didn't mind at all. Okay. So now let's think about this.
Well, I guess it's not returning anything. So
Yeah, all it's doing is initializing the y. Can we print out y?
I mean, I don't see why not.
Okay, very good. So now
As far as I see it,
right. So we have the name. We have the on line 12. I have the object dot x. It prints the class variable, right?
Mhm.
Now I'm going to do print sim object dot y.
You don't need to say the INT function.
And that's the weird thing. Usually, all the variables are defined here. So in Java, what happens is you use the constructor, you have a list of variables up here. And the constructor then initializes them, but they're defined here. But but in Python, the class, the instant variables are here. And so now if I print them up, let's see if this works. And it says has no attribute y. The simple object has no attribute y. So this did not work, as you were kind of suspicious, right? So what do we need to do? I think this is what we need to do.
Always points back to self.
We're back on the self. I think this will work.
Oh,
You're better or
yeah.
there you go. So you can see the difference here. When we declare instance variables in the constructor, we need to have the self. When we declare class variables, we don't need the letter word self. But when we are accessing class variables inside some function in the class, we need self. When we try to access a class variable from inside a method, we need a self before it. The local variable declared in this method doesn't need self because it's local to the variable. This local as in local, the scope. Outside of this method, Z does not exist.
Gotcha.
Okay. All right. Now, one thing before we do the review, let's do this. Simple, I could put here 67. And if I did that, it's gonna say it doesn't work. I'm passing in an argument, and there is no place for the argument here. Because self is an argument for simple is a call to this function, right?
Sure.
So I'm passing 67. So I need another argument here. So let's call it y. So now when simple gets invoked, self gets passed, the pointer to the instance, and y will be assigned the value 67. And then inside this function, I'm going to do this. If I did this, it wouldn't make any sense.
Right, because it's declaring itself.
So I'm assigning what? I'm assigning 67 to 67. What we want to do is, so what we want to do is we want to do this. That's one way to handle it. The other way to handle it is that we could have just named it something else, like age. And that will work as well.
Do you need the self? If it's
You still do. Yeah.
So if it was y equals y, it would just show us an error. Wouldn't show.
So this would be 67. This y would be just local to the header here.
I see.
And then it would be a local variable. Y would be local variable here, and y would be sitting here, and so the value of y would be changed, would be assigned 67 here, and then it's here is being used, and so the y would be seen to store the value 67, but it would be assigned to the instance variable y that actually belongs in that object or in that class.
Right.
Defined in that class. Okay. All right. So I don't want to create an object. I just want to access the class variable. It turns out all I have to do is use the class name. And this should work. Unless it complains about the constructor, which it won't. Because we didn't even call it. There you go. Do you see that 5 shows up?
Oh yeah.
Yeah.
Makes sense,
So how did we access this is the class variable? Let me type that in here. Class variable. We were able to access the class variable by using the class name. What's the second method of accessing a class variable? We can we can go to one of the objects of the class, put that in there and call it. In this case, it won't work because we haven't instantiated an object. So let's do that here. So line 7, we instantiate an object of the class simple. Now we have the object simobj. Now in line 8, we print out the value that is stored in the class variable by using the class name. In line 9, we use the object that we just instantiated in line 7 to access the same class variable. So there are two ways to get to the class variable. And there's only one way to get to functions and instance variables, which is through the variable. So there are two ways to get to the class variable. And there's only one way to get to functions and instance variables, which is through the object. Class name only gets you to the class variable. Unless there was a thing called a class function, which I don't know if there is. I don't think so. Okay, so to repeat myself again, in order to print out y, we can't do this. Line 10 will not work. In order to access instance variables, we need an instance. We need an instance here, as in simobj. So I would comment we need an instance, which is another fancy word for object, right? X, right? In order to access a class variable, we can use class name. We can use the name of the class dot X. For instance, Y, I should have typed that there, right? So if you go to line 10, what I wanted to say was you need an instance, an actual object, in order to access Y, which is an instance variable. When you're accessing class variables, you can use the class name and dot notation and the class variable name, or you can use also an instance dot, which is what's happening here in line 9.